Suppose you have two intersecting lines. This angle over here happens to measure exactly 50 degrees. Notice that this angle over here is supplementary to the 50-degree angle because together they make a straight 180-degree angle. So what's the measure of this supplementary angle? If you're not sure, click over here to review. Exactly, this angle is 180 degrees minus 50 degrees, or 130 degrees. Next, take a look at this angle down here. It's supplementary to the 130-degree angle because together they also form a straight 180-degree angle. So what's the measure of this angle? Right, just like the first angle, this angle also measures 50 degrees. And finally, this angle down here is supplementary to this 50-degree angle as well as to this 50-degree angle. So what's the measure of this angle down here? Nicely done. So this angle also measures 130 degrees. So we have two pairs of congruent angles here, meaning angles that have the same measure. On opposite sides of this intersection, we have a pair of 130-degree angles, and we also have a pair of 50-degree angles. Angles on opposite sides of intersecting lines are called vertical angles. They're called vertical angles not because they run up and down, but because they have the same vertex or corner at the intersection. And as you've shown in this example, vertical angles are always congruent to each other, meaning they always have the same measure. So take a look at this pair of intersecting lines. Of the four angles here, select two that are a pair of vertical angles. Right, these two angles are vertical angles. They're on opposite sides of the intersection and they have the same measure. And which two angles represent the other pair of vertical angles? Now in this interactive, you can rotate these two lines by dragging them around. One pair of vertical angles is colored yellow and the other pair is colored blue. Try moving these lines around to make sure that vertical angles are always congruent. Then try answering this question. If both pairs of vertical angles have the same measure, meaning all four angles at this intersection are congruent to each other, then what is that measure? Okay, so let's try another problem. Suppose you have three lines that all intersect at a single point. This angle has a measure of 72 degrees, while this angle has a measure of 65 degrees. So try using what you know about vertical angles to find the measure of this angle over here. If you get stuck, just click over here and we'll figure it out together. Excellent! There were a few different ways you could have solved this using supplementary and vertical angles, and this angle measures 43 degrees. This angle is also 43 degrees because these are a pair of vertical angles. Similarly, this angle measures 72 degrees and this angle measures 65 degrees. So vertical angles, which are angles on opposite sides of two intersecting lines, are always congruent to each other, and you can use this fact to find the measures of unknown angles at intersections. Okay, here's your final challenge. Suppose you have two intersecting lines and I tell you that this angle measures 2x plus 30 and this angle measures 7x minus 25. Try using this information to solve for the variable x and click down here if you get stuck. Nicely done! You set these two expressions equal to each other and found that x equals 11. So finally, let's double check your answer. Try plugging in 11 for x in both of these expressions and make sure you get the same measure for both of these vertical angles. Take a look at these four lines here. Which two of them are parallel to each other? Exactly right. These two lines are parallel, meaning they run in the same direction and they never intersect. Let's draw in another line that crosses the parallel lines. You'll often hear a line that crosses parallel lines called a transversal. The transversal forms quite a few angles with the parallel lines. These four up here and these four down here. Some of these angles are congruent, meaning they have the same measure. For example, which other angles are congruent to this orange angle up here. Nicely done. So these four angles are all congruent to each other. Now angles that have matching positions along a transversal are called corresponding angles, and they're always congruent. So if we look at this angle over here, which is at the top right side of this intersection, we say it's corresponding to this angle down here, which is at the top right of this intersection. So this is one pair of corresponding angles, and they're congruent. Here's another pair. Both of these angles are in the bottom right of the intersection. And here's yet another pair of corresponding angles in the bottom left. So finally, which angle is corresponding to this one over here? Exactly, these two angles are corresponding. They're both on the top left of their intersections along the transversal. Next, take a look at these lines here, where these two are parallel to each other and this line is a transversal. Among the 8 angles here, go ahead and pick exactly 2 angles that are corresponding. Nicely done. Now for a final challenge, take a look at this angle down here. Suppose it measures 120 degrees. Try using corresponding and supplementary angles to find the measure of this angle up here.